All right, hey everybody. So we are moving on to our next lecture now for Unit 2. This is going to be all about the atomic structure. So this is lecture 2.2. So once again, make sure you have out your notebook and a pen or pencil so you can take notes and follow along with me. All right, so let's get into it. So here we are, atomic structure. We're looking more at the atom and how we can represent the atom, and how do we draw this, and we're going to look at the structural components of it. So here, I talked about this briefly at the end of lecture 2.1, but I want to go over it again, is that when we're looking at the periodic table, there's a lot of useful information on there, but we got to make sure we understand how to use that information. So first off, we have the letter, this big letter in there, and that's going to be the symbol or the name of the element. And this one, this big N, is representative of nitrogen. We also have a number, sometimes it's in the corner of it, of the little box, and that is referring to the atomic number. And what it says right here is exactly what it is. It is going to be the number of, really we should focus on, it's the number of protons, and it also is the number of electrons in a neutral element or neutral atom. So because there's no plus or minus after the 7, we know it's neutral. And so this means that the number of protons, which is positively charged, and the number of electrons, which are negatively charged, are exactly the same. So we have 7 positive protons and we have 7 negative electrons. So really it's like when you put them together, it's a neutral charge. There is no charge because the negative and the positives are exactly the same. And then we have the atomic mass, and the atomic mass, like it's written out right here, the atomic mass is equal to the protons plus the neutrons. So if we know the atomic mass and if we know the number of protons, can we figure out the number of neutrons? Definitely, we can definitely figure it out. And the way you can do is you take 14, which is my atomic mass, so I just brought that down here. That's the atomic mass, it's a total atomic mass. Remember, it's equal to the number of protons. We know the number of protons is 7, right? We know that. So here we go, we have a 7 plus neutrons. Do we know the number of neutrons? It doesn't necessarily tell us in there, so we could just leave that as n. And then we just gotta solve for n. And so you subtract 7, from both sides. Sorry, I ran out of room here, but 14 minus 7 is telling us that n, oh gosh, n, it's not a very good n, fix that. N is equal to 7, which is referring to the number of neutrons. So now we know that the protons is 7 and neutrons is 7. So that's how you can figure that out. Okay, so let me clear the screen and move to the next slide. And once again, here is our periodic table, and exactly what I did on the previous slide. You can apply that information to any of these elements. So you can figure out the number of protons. So if we're looking at boron, we can figure out the number of protons and electrons by looking at the atomic number, which is here. So we know that this element, boron, has 5 protons and it has 5 electrons because it's neutral. And we can also figure out the number of neutrons by looking at the atomic mass, which is 10.8, if I can see that clearly, 10.8, and you can minus that from 5, and that'll give you the neutrons. Okay? So what we're going to do now is I want to do a little bit of practice. So the nitrogen atom has 7 protons and 7 neutrons. How many electrons does it have? What is its atomic mass? And we want to draw something called a Bohr diagram. So a Bohr diagram is going to be showing all of these subatomic particles and how we can show that in a diagram, in a model, in a drawing. So we're going to be working on that. So let's answer these questions. So if the nitrogen atom has 7 protons, then how many electrons does it have? I'm sorry, yeah, exactly. How many electrons does it have? Since it's neutral, 7 electrons. What's its atomic mass? Remember that the atomic mass is protons plus neutrons. So it's protons plus the neutrons. So we would just do 7 plus 7, and that's going to give us atomic mass of 14. All right. The next thing that we want to do is we are going to draw the Bohr diagram. So please make sure that you are drawing this with me so that you know how to do this. It's really not that hard. Once you have all the information, once you know the number of protons, once you know the number of neutrons, and once you know the number of electrons, it makes it pretty easy to do this. So first thing you want to do is I like to start off with a nice circle in the center like that. This is going to be my nucleus, my nuclei of the atom. And what's inside of the nucleus of the atom? Well, it's the protons and the neutrons. So I put a P here. P is equal to my number of protons, which is 7. You can put a little plus sign if it helps you. Protons are positively charged. So you have 7 protons floating around or kind of in that nucleus. And then the number of neutrons is equal to, where is it? Here it is, 7. There we go. Now we also have to figure out these electrons. And remember, the electrons are going around the nucleus of an atom. And so what we want to remember is that first orbital. So if we're looking at that first orbital of an atom, how many electrons can go around the first orbital? It's 2. A maximum of 2 can go around the first orbital. So let's do that. I mean, we have a total of 7, so we definitely can fit 2 on there. So I'm going to use, let's see, what color should I use? Let's use red. We'll use red to represent the electrons. So red will represent electrons. So I represent them with little circles like this, and typically I like to separate them. I mean, you could put them right next to each other, but it looks better. Just separate them out. So one electron on this side and another electron on that side. So now we have to figure out, okay, if we used up 2 of them, we got to figure out how much our second orbital is going to have. And remember, how much does a second orbital? What's the max number of the second orbital? It can be a max of 8. That doesn't mean it will have a max of 8. But we need to figure out for nitrogen specifically, how many will that second orbital have? We know we are going to need a second orbital, at least 1, right? Okay, let's see. So if we have a total of 7 electrons, right? We know that nitrogen has a total of 7 electrons, and we already used 2 of them, so we can say, okay, well, I used 2 in the first orbital. I used 2 electrons in the first orbital, so that then means I have a leftover of 5 electrons. So I have 5 electrons left over. So let me get out my color of red. That means I'm going to space out my second orbital. I only have 5 electrons left, so I would space them out. I would put 1 here, 1, 2, 3, and 4. I always like to space them out like that. Once I get to my 4th one, then I start to double it up. So I have 1 more, so I'll put my other one up here, my other electron up there. And that's a Bohr diagram. That's really it. Sorry, it's kind of hard to draw, but yours should look a little nicer than that. And so that is what a Bohr diagram looks like, where you have your protons and neutrons on the inside of the atom in the nucleus, and then you have your electrons that go on the outside of it. Okay, and that's how you do it. So let's go on to our next slide. Clear the screen so we can move on. Here we're going to do a little bit more practice. So I want you to pause the video and attempt to answer these. So you look at the hydrogen atom. It tells you the information here, and then it tells you all the information of the atom in the drawing, and then it wants you to answer these questions. And then for lithium, it's opposite. It gives you all the information, and then it wants you to draw the Bohr diagram. And then bromine is similar to the first one, where you look at this and then you answer these, fill out the atomic number, atomic mass, electrons, and valence electrons. As a reminder, the valence electrons are the electrons on the outermost shell. So if it has 1 shell, it's the electrons on that first shell. If it has 2, then it's the electrons on that second shell. So I want you to give that a try, and then I will go over them with you. All right, so let's go over it. Get this out. I will use blue to answer the first one, hydrogen here. So it asks for the atomic number, and the atomic number is the number of protons. And protons are found in the nucleus, and it tells me exactly what they are right here. Protons, P, is equal to 1. So I know my atomic number is 1. Good. The atomic mass is going to be the number of protons and neutrons. So we figure that out by adding protons and neutrons. So that's going to be 2. Number of electrons are always on the outside of my atom in the orbital. And so if we're looking at this, you can see there's only 1 electron there. It's represented with that circle. And so that should only be 1. Now the valence electrons is going to be the electrons that are on the outermost orbital. And so there's only 1 orbital, and so there's only 1 valence electron. So that's not too bad, right? So those are the answers for our first one. Now for our lithium, we need to actually draw the Bohr diagram. So I always start off with my circle in the middle, and I will put in my number of protons and my number of neutrons. Now it doesn't specifically tell you the number of the protons and neutrons, but we do know that the atomic number, number 3, is the protons. So that's that. I can figure that out. Okay, good. So I figured out the number of protons because the atomic number is equal to the number of protons. So P is going to be equal to 3. Now what about the number of neutrons? Does it say it here? Can we even figure this out? We have to remember that the atomic mass is equal to the number of protons plus neutrons. So if I know that I have atomic number of 3, I have 3 protons, then I can just subtract 3 protons, really positive, I'm just putting a positive sign there just to say that's 3 protons. So 6 minus the 3 protons is going to give me 3 neutrons. So N is going to be equal to 3. Okay, and from these examples you can see that the number of neutrons and protons equal each other. That is not always the case. These examples are showing that they do equal each other, but the protons and neutrons don't always equal each other. All right, now we have to figure out the electrons. So we know we're going to need at least 1 electron shell. And now let's look at our number of electrons. And I'll do that again, I'll do that in red. So number of electrons here is equal to 3. We know that our first orbital can only have a maximum of 2 electrons, so that's 1, now that's 2, but we have 3. And it's actually even telling us our valence electrons is equal to 1. So that means that our outermost electron is going to be 1. So let me draw that. We get our red back. And so we have 1 valence electron, and that makes a lot of sense because we had a total of 3 electrons. And you can double check your work. Oh, that's a different color, but that's okay. To just show that we have our number of electrons. We have 1 electron, 2 electrons, 3 electrons, and we are all set to go. All right, so now let's work on our last problem, which is with bromine, and we want to look at what's going on here. So we want to look at the atomic number first, and I'll do that in pink. Atomic number is the number of protons, and we can look on the inside. And we say protons is equal to 35. So we know that the atomic number is equal to protons, so this must be 35. Atomic mass is going to be equal to the number of protons plus the number of neutrons. So 35 plus 35 is 70. And then the number of electrons. Now you can figure out the number of electrons in a couple of ways. You can either count all of them, count every single one of these electrons. That's a lot of electrons. Instead, you just have to remember that the number of protons and the number of electrons are equal to each other when we have a neutral atom or a neutral element. There's no plus sign or minus sign after our bromine, which means that this is a neutral element. So protons and electrons will equal each other. So I can just tell that this number of electrons must be 35. If you want to check your work, you can, and you can count them. That's up to you, but I don't want to do that because I know that the number of electrons will be 35. For the valence electrons, though, I would count them because that's going to be my outermost shell. Here's my outermost shell. There's really not too many to count. We have 1, 2, 3, 4, 5, 6, 7. So our number of valence electrons should be 7. And those are the electrons, once again, these outermost electrons, those are the electrons that are going to be interacting with other atoms. Okay, so let me just make sure that you can see that. Sorry if my face was just blocking all that information, but I just moved my face so that you can see this. Sorry if I probably was blocking some of that. But now here are all the answers just to double check, right? Valence electrons, the way I got that was I just counted the outermost electrons. All right, so make sure you have all of these answers correct in your notebook so you can always refer back to them when we have quizzes or we do activities, so you have all this information to look at. All right, so I'm going to clear the screen, make sure you have everything. Come on, let's go to the next slide. All right, so now this next slide is going to be looking at chemical bonds. And so what that's referring to is that atoms that do not have a complete outer shell will either share, donate, or receive electrons. So really quick, this one is showing that because they don't have a full outer shell and they want to fill it, they want to have a full outer shell, they're going to actually share electrons. And that's going to form this bond right here. If there are two electrons that are connected to each other, that's a single bond. Or what could happen is you can transfer electrons. And one electron will move to the other atom. That transfer is called an ionic bond. So covalent bond is sharing, and ionic bond is going to be a transfer. So covalent bond are very, very strong chemical bonds, and this is when they're actually going to share one or more pairs of outer electrons. So two or more molecules that are held together by covalent bonds, that is called a molecule. So here are some examples of molecules. Carbon dioxide. The oxygen and the carbon are going to be connected. You can't see them, but there are covalent bonds right here that are holding this molecule together. This molecule right here, this is actually called glucose. And there are covalent bonds holding it together. These sharing of electrons that are holding it together. Same with water molecule. There are covalent bonds that are holding the elements together to form a molecule. And there could be single bonds, which is when you have one electron from hydrogen, one electron from this hydrogen, and then they are going to be shared together. And so now you have a single bond. But if you have a double bond where you have two electrons, let's say from oxygen, two electrons from oxygen here, now you can see there's four. That actually equates to two bonds. Triple bond is actually when you now have three electrons from nitrogen, three electrons from this nitrogen, and then they share. That's a triple bond. Right, so here it is, right, the three electrons from each nitrogen, and that gives us a triple bond. So we have a single covalent bond, once again, is going to be when you have the two electrons that are going to be interacting like that. That's a single bond. And then a double bond is really when you have four electrons that are connected. Really, it's like 2 and 2 forms the double bond. And then ionic bond is going to be the complete transfer of the valence electrons. So NaCl, which is table salt, which I'm sure you're all familiar with that, is actually a good example of the transfer of our valence electrons. And this is called an ionic bond. So this is a very good example of that. So we can notice that our sodium, which is Na, is going to have this outer shell, only has one electron on the outside, only one. So then when we look at the chlorine atom, it actually has 7 electrons. So that electron from sodium is going to transfer over to the chlorine, and it's going to help give it that full outer shell. And that's what we really want. We want it to have that full outer shell to form that octet. So what we're looking at now is the fact that because sodium lost an electron, it now has a greater number of protons compared to electrons. So it's now positively charged. So we have less electrons here now, versus our chlorine ion is now going to have, and you can see, oh, let me just refer back to this, Na+. So now we see, okay, this has a positive, which means that there's actually greater number of protons in comparison to electrons. And then here, the chlorine is going to have a negative sign right here, which actually means that it has a greater number of electrons because it gained an electron compared to its protons. So we say that's actually negatively charged. And the definition of an ion, which is up here, is an atom or molecule within an electrical that has an electrical charge due to a gain or loss of electrons. So it could be a positive ion or it could be a negative ion. All right, so those are our notes looking at our Bohr diagrams and looking at our bonding, and we're going to do some activities that'll go along with that to really emphasize what those points are and to explore them a little bit further. But I hope that was helpful, gives you a good start, and if you have any questions, please email, or you can ask a question at the end of the video and I will answer them. Okay? All right, so I hope that was helpful and have a great day. See ya.